Right, testing my mic here. Okay, that sounds good. And oops, what did I do here? The cord of my mic is stuck again. It happened last time too. I believe my audio should be good. So, yeah. Let me switch to my overlay here. And there we go. We are live back once again. Now, you may have noticed I changed the title. So I used to say day one, day two, day three, but I replaced it with the word stream as that is more accurate. Also, I realized that the last stream got cut off abruptly. Abruptly, is that how you pronounce it? Anyhow, there was a power cut, a power failure that occurred here, so that's the reason. And anyhow, I did cover a majority of what I had intended to, so but I might as well just cover the rest in the next stream, which happens to be this stream. All right, so um. Without any more further introductory jargon, let me begin. There we go. Is my yeah, both of my audio is turned on and everything looks good. The resolution is also correct. The reason I'm double checking is because there have been times where I forget to send the recording to YouTube at the same time, and yeah, well, not times. It just happened one time, but for the safe time, sorry.
We'll have an eat method. All we're gonna do.
So I know we started off with the inheritance part of it, inheritance segment a bit. I'm just gonna continue from here.
Is console.log. I'll use a template string. This. Now I'll add a placeholder. This dot name is eating, and a sleep method. Sleep. This dot name is sleeping. Animal will be the parent class. We'll create children classes that inherit these properties and methods. Let's create a few children classes. Class rabbit. Our rabbit class will inherit all the properties and methods of the animal class. To declare a parent-child relationship, the child will extends the parent animal. For the rabbit, I'm going to give this class a name. Name equals rabbit. This will be a property. If you're familiar with the static keyword, you can make the static. Now we'll create a fish class that also extends animal. Class fish
Should it be this dot name though?
extends animal. Fish will have
Because
one
you don't
property.
have to
Name
do
equals
that. It
fish.
automatically
And a hawk class.
recognizes it.
Class
Maybe.
hawk extends animal. We'll have one name property.
Or I was about to say it might be a class variable, but if it was a class variable, it should do animal dot name, right? Anyway, I guess we'll just continue and see.
All right, let's see if this works. If we create a rabbit, fish, and hawk object, they should have access to these properties and methods. Let's create const rabbit equals new rabbit. Const fish equals new fish. Const hawk equals new hawk. All right, let's see if our rabbit has an alive property. Console.log. Take the name of the object, rabbit, dot, access a property or method. Alive, that's a property. The rabbit is alive. But what if the hawk swoops in and kills the rabbit? Let's change the alive property of the rabbit. Rabbit.alive equals false. The rabbit is no longer alive. Now let's see if our rabbit has access to a eat and sleep method. Rabbit.eat. This rabbit is eating. And sleep. Rabbit.sleep. The rabbit is sleeping. Let's test this with fish. Fish.alive, fish.eat method, fish.sleep method. The fish is alive, the fish is eating, the fish is sleeping. And hawk. Hawk.alive, hawk.eat method, hawk.sleep method. The hawk is alive, the hawk is eating, the hawk is sleeping. Our children classes of rabbit, fish, and hawk all inherited the properties and methods of the parent animal class. This helps with code reusability, because I don't need to declare all of these properties and methods within each of the children classes.
Yeah, let's just check real quick whether that worked. And yep, I expect that to pop up. Okay, so just visit the website here and yeah, looks good.
Is like this. We're saving a lot of lines of code. It's not that apparent with just a few child classes, but imagine if you had hundreds of different child classes. Well, by using inheritance, you would be saving a lot of time. But not only that, the children can have their own unique properties and methods too. For example, rabbits will be able to run, but fish and hawks can't run. That's a method that only belongs to rabbits. Within our rabbit class, let's create a new method, a run method. We'll console.log. I'll use a template string. This, add a placeholder. This.name is running. Within our fish class, let's create a swim method. swim. This.name is swimming. And hawks will be able to fly. We'll create a fly method. This.name is flying. Let's minimize these classes. Let's take our rabbit object, display the alive property, the eat method. Let's minimize these classes.
Alright, let's create swim and fly too. Okay, I misspelled this as if that. Um, did I add an extra bracket or something? Or is it because I did not end these? Yeah, that had an extra bracket, I believe. Then. Hmm, Let's call fish.swim, um, rabbit.run, and hawk.fly. See what happens. There we go, that's working.
Let's take our rabbit object, display the alive property, the eat method, the sleep method, and the run method. Rabbit.run method. The rabbit is eating, the rabbit is sleeping, the rabbit is running. Now let's do this with fish. Fish.alive, fish.eat method, fish.sleep method. Now does the fish have a run method? It does not. Fish.run is not a function. Run is a method that belongs to the rabbit class. Fish can't run because, well, they don't have legs. We did not give our fish class a run method. They can swim though, but they can't run. Fish.swim method. The fish is swimming. Let's do this with hawk. Our hawk cannot swim, but it can fly. We'll use the fly method. The hawk is eating, the hawk is sleeping, the hawk is flying. And of course, our rabbit can't fly or swim. Does our rabbit have a fly method? It does not. Rabbit.fly is not a function. Alright everybody, so that's inheritance. It allows a new class to inherit properties and methods from an existing class. A child inherits properties and methods from a parent. It helps with code reusability. I don't need to declare all of these properties and methods for each of these classes. I can simply reuse it. That helps us follow the dry principle. Don't repeat yourself. And well everybody, that is an introduction to inheritance in JavaScript. Yo, what's going on everybody? So in today's video, I'm going to explain the super keyword in JavaScript. Super is a keyword that's used in classes to call the constructor or access the properties and methods of a parent. The parent is also known as the superclass. It's very similar to the this keyword. This refers to this object.
Yeah, we also have the super key. Actually, it's not a super key, but more like a function. Maybe it's used as a function too here, but same thing. I guess super is just used between in other languages too. Maybe not sure on that one
Super
though.
refers to the parent of that object. Here's an example. We'll use inheritance to create a parent class of animal. Class animal. Our animal class will have 3 children, also known as subclasses. Class rabbit extends animal. Class fish extends animal. Class hawk extends animal. We'll add an empty constructor for now for the animal class. Then we need a constructor for the rabbit class. So rabbits, they'll have a name property, age, and a run speed. We'll assign these properties within the constructor. This.name equals the name that we receive. This.age equals age. This.run speed equals run speed. Let's copy this constructor. Now with fish, fish don't have a run speed, but they'll have a swim speed.
Alright, let's just copy those here. Hmm. So name and age and run speed. Let's set the variables. Then goes here except fish. Fishes can't run, so we'll replace that with swim speed. We'll copy this too, except we'll change run speed to swim speed. Lastly, we'll copy this here, and we'll call it flight speed.
Let's replace run speed with swim speed. Copy the constructor again, paste it. Hawks in this example won't have a swim speed, they'll have a fly speed though. Replace swim speed with fly speed. Now let's attempt to create some of these objects. Const rabbit equals new rabbit. We need a name for this rabbit. You could just say rabbit, or if you want to be creative, you could say something like Bugs Bunny. But let's just stick with rabbit to keep it simple. Our rabbit will be 1 year old and has a run speed of 25 miles per hour. If you use kilometers, feel free to use kilometers. Let's do this with fish. Const fish equals new fish. The name of our fish will be fish. Our fish is 2 years old and has a swim speed of 12 miles per hour. Then with hawk, const hawk equals new hawk. Our hawk will have a name of hawk. Our hawk will be 3 years old and has a fly speed of 50 miles per hour. So when I run this program, we have an uncaught reference error. Must call superconstructor in derived class before accessing the this keyword. So it
Must call super constructors in derived class. Oh, is this the reason why I didn't use constructor in the... Oh, I see, I see.
JavaScript is telling us
It will
that
run
before we
this
can use the keyword, we
constructor
have to call
once
the
we do
constructor of the
that.
parent, the superclass. Within each of these respective constructors,
So we can change name and age to year, maybe?
we will invoke the constructor of the parent, the superclass, with the super keyword. So let's do that for each of these constructors. Now our program actually runs now. So one of the benefits of using constructors is that if there's any properties that the children all share in common, we can send them to the constructor of the parent. As you can see, we're repeating ourselves a lot. Each of these children classes has a name and age property that we're assigning to each. We would like to follow the dry principle. Don't repeat yourself. So why don't we write this code once and reuse it? So within the constructor of the parent, we'll accept a name and age property. We'll assign this.name equals name and this.age equals age. Now we can remove that within each of the child classes so we don't repeat ourselves. There's less code to write now, but we do need to pass in these arguments to the parent constructor, name and age for each. And that's all there is to it. In this example, when we construct an object, either a rabbit, a fish, or a hawk, we'll accept 3 arguments, a name, age, and either a run speed, a swim speed, or fly speed depending on the animal that we're creating. Any properties they share in common, we can send to the parent constructor. It helps with code reusability, and there's a lot less to write. It's not that evident with 3 children classes, but imagine if you had hundreds of different classes. Like what if this was Pokemon? There's like, what, 1,000 Pokemon now? We would have to copy and paste those properties like 1,000 times for each, if we're constructing individual Pokemon. But since all of them share those same properties, we can write it in one place, and make any changes only in one place. So let's test this to see if it works. Let's console.log our rabbit's name, which is named rabbit. Let's console.log the rabbit's age. The rabbit is 1 year old, and let's see if the rabbit has a run speed. 25, as in 25 miles per hour. Let's do this with fish, fish.name, fish.age. Let's see if the fish has a run speed. Name is fish, age 2. Run speed is undefined because fish can't run because they don't have legs, but they do have a swim speed though. Swim speed, 12 miles per hour. Then hawk. Hawk.name, hawk.age, hawk.fly speed. Name is hawk, age 3. The hawk has a fly speed of 50 miles per hour. So that's how you can use the super keyword in a class to call the constructor of the parent. It helps with code reusability. Any properties that the children share in common, in this case a name and age, the constructor of the parent can take care of that. We don't have to repeat this set of code every single time for each child. We write it.
And we got an error and called age is not defined. See what can be the error here. Of course, name comma age. And yeah, that worked, didn't it? The speed is 50 kilometers an hour.
In
So
one
that
place and
worked.
reuse it. Another thing you can do too with the super keyword is extend a method from the parent. So what we're going to do within the animal parent class is create a move method. Within this method, we will console.log the following message. Add a placeholder, this.name moves at a speed of, add a placeholder, speed, mph for miles per hour, or if you prefer, you can use kilometers. Our move method will have one parameter, a speed that we need to pass in to use. So within each of these children classes, we'll write a method that also extends the move method of the parent. Rabbits will have a run method. We'll output the following message. Console.log, I'll use a template string, add a placeholder, this.name, can run. Let's copy our run method, paste it for fish, but change swim to run because fish can't run. This.name can swim. Then with hawks, they'll have a fly method. Fly, this.name can fly. Run method, paste it for fish.
Right. Let me guess, we'll call move inside each of their individual specific movement function, movement method, as I should say. So it's swim, and then finally we'll have fly.
But change swim to run because fish can't run. This.name can swim. Then with hawks, they'll have a fly method. Fly, this.name can fly. With our rabbit object, let's invoke the run method. This rabbit can run. Let's do this with fish. Fish.swim. This fish can swim. And hawk.fly method. This hawk can fly. Within each of these children classes, we're going to extend the move method of the parent animal. Within the run method of our rabbit class, not only are we going to output this message, we'll also extend the move method of the parent and display that message as well. To refer to the parent class, we use the super keyword.
Can we, we should be able to do hop.move, right? Speed is not defined, okay.
It's very
Of course, of course.
similar to this, but it means the parent. Use the parent's move method. But we do have to send a speed argument. Let's send the run speed of the rabbit, this dot run speed. Let's do this with our fish class. We'll extend the move method, super.move, send in this dot swim speed, and hawk.
I use the brackets there because that's how I believe you do it on Python. I'm just used to that. So what is this rabbit, right? Let's just do the same with the other ones here real quick. So rabbit.run, fish.swim, and hawk.fly. See here. Yeah, there we go. That is good.
Super.move, this dot fly speed. Now let's take our rabbit, use the run method, and we should extend the move method. This rabbit can run. The rabbit moves at a speed of 25 miles per hour. Let's do this with fish. Fish.swim. The fish can swim. The fish moves at a speed of 12 miles per hour. And hawk. Hawk.fly method. This hawk can fly. The hawk moves at a speed of 50 miles per hour. So that's how you can use the super keyword to extend a method of a parent. Alright everybody, so that's the super keyword. It's a reference to a parent. It can be used to call the constructor of a parent and or access the properties and methods of a parent. And well everybody, that is the super keyword in JavaScript. Hey, hello. So today I'm going to explain getters and setters in JavaScript. Getters are special methods that make a property readable. Setters are special methods that make a property writable. We can use getters and setters
Yeah, this has it.
to validate and modify a value when reading or writing a property. It helps with validation when creating an object or updating one of its properties. Here's an example. We will create a class of rectangle. We need a constructor. We will have two parameters, a width and a height. We will assign this dot width equals width. This dot height equals height. Now let's create a rectangle object. Const rectangle equals a new rectangle. For the width, let's say -1 million, something ridiculous. And for the height, I want the height to be pizza, the word pizza. Then let's console.log our rectangle's width and the rectangle's height. We have created a rectangle object with a width of -1 million and a height of pizza, which doesn't make any sense. We could use some validation when creating an object. We don't want people to enter in garbage values like -1 million or string when we're expecting a positive number for the width or height. That's where getters and setters come in. We'll begin with setters. When setting one of these properties, either initially through a constructor or updating one of them later, such as setting the width or height equal to some value, we can go through a setter first. Outside of our constructor, we will set a property. We'll begin with width. This will be a special type of method. The parameter will be new.
I believe we of course have getters and setters in Python. But to do it in I can't remember, like what do they call this? Like you use the at symbol and I think it's called decorators, right? Yeah. Hmm. Actually, let's just search that real quick. Getters and setters in Python. So okay, but yeah, I get it, but it's like if you actually try to change it, like just using the variable name. So it will be here. Let's just check. Hmm. It's in this article perhaps. Get text, set text, get font, set font. I'm looking more so at rather than creating functions. Uh, using properties instead of getters and setters, the Python way. Ah, okay, alright, okay. Maybe this is the one perhaps. Ah, there we go. We use a property. I believe it's called the decorator. That simple decorators in Python. It basically wraps the function around. Let me just check if. Yeah, that's the one. Alright, they would probably be using. I'm just control F and search for it. Ah, there we go. Easy way to apply decorators. Cool. So yeah, just want to show that. Let's go back and
Width.
check what this is
What do we want to
about.
check before assigning this property? Using an if
Oh, you
statement,
do it
let's check to
in
see if the new
JavaScript.
width that the user sends us is greater than 0. If it is, we will assign this dot underscore width. Using underscore.
We have a separate keyword for that apparently. So set width.
For prefix, it tells other developers that this is a private property. You shouldn't touch it at all. You could say that this private property of width is different than our standard width property. We will assign the private property of width equal to the new width we receive. Else, let's console.error, not log, we'll use error this time. Width must be a positive number. Alright, let's see what happens. Width must be a positive number, and our width is currently undefined, which is good. Okay, let's do this with height. Let's copy our setter for width, paste it, but change every instance of width to be height. Set height, new height. Be sure to use that camel case naming convention. If new height is greater than 0, assign the private property of height equal to the new height. Else console.error, height must be a positive number. And there we go, that worked. Width must be a positive number, and height must.
Just do the same for height real quick. We'll need to change that and these places here. I can change that, and here we'll just lowercase it.
Must be a positive number. Our width and height are currently undefined. In order to set the width and height, we have to pass in a positive number. For the width, I will say 3. For the width, 4. Now when we access width and height, those numbers.
Let's just create a rectangle real quick. Also, let's just see what happens if we put in random values here. But I keep on closing the local host every time. There we go. That should add it out. Yeah, add it out as expected. Let's set it to. Yep, now only height is out. Okay.
Numbers still aren't showing up. That's because these properties are writable via setters, but they're not readable. That's where getters come in. We'll create 2 getters. One for width. We'll need to use the get keyword, get width. This will be another type of method. All we're going to do is return this private width. And that appears.
I mean, what's the problem with doing this? Don't do that, right? Oh, because it kind of runs into an infinite recursive loop thingy. Because at this point you're setting width again, so you can't it runs the function again. Because you have to use this secret variable format and then have a separate get keyword function thingy.
Appear to work. We have 3 for the width. Let's do so with the height. We will return this private height. We have 3 and 4. Now by using setters, we can even update those values later. Let's take our rectangles, width, set that equal to be 5, take the height, set it equal to be 6, and that also appears to work. But again, if I try and update those values to some garbage values like -1,000,000 and the word pizza, we get those errors again. And our object retains its initial values that we previously assigned it, 3 and 4. With getters, we can even use the property accessor, that dot, to access a property that doesn't necessarily exist. For example, we will get area. We'll perform a calculation. We will return this private width times this private height. So now, we can access area as if it was a property. We have 3 for the width, height 4. Our width times our height gives us an area of 12. Our area isn't a property technically, it's not found within our constructor, but we can access it as if it was a property with a getter. With getters, you can even add additional logic. I would like to preserve the initial values of our width and height. When I return their value, I will use the toFixed method to give each of these a precision of 1. Let's do that with the width, the height, and the area, but that's going to be a little more complex. We'll enclose width times height, then add toFixed 1. And why stop there? I'll add centimeters to the end of each. I'll use a template string, add a placeholder, then add cm for centimeters, 3.0 cm, and the area, 12.0 centimeters. Let's make that centimeters squared because it's area technically. When you're assigning values, even when you're initially creating an object, you can go through the setters for input values. Let's make that centimeters squared because it's area technically. When you're assigning values, even when you're initially creating an object, you can
And this should return. Yeah, there we go, with the proper unit and all.
go through the setters for input validation. When you retrieve values and try and read them, you can add additional logic too. Let's go over a second example. We will create a class of person. We need a constructor. We will accept a first name, last name, and an age. This dot first name equals first name. This dot last name equals last name. This dot age equals age. Let's construct a person, const person equals new person. Let's enter in some values that don't make sense. The person's first name will be the number 420, their last name is the number 69, their age is the word pizza. Let's console.log our person object's first name, which is the number 420, their last name, 69, and their age, the word pizza. We need to validate this input before assigning the properties. That's why we need setters. We will set the first name property. This is a special type of method. The parameter is going to be a new first name. We need to be sure that this value passed in is a string and the length is greater than 0. We could write something like this. We need an if statement. Let's check the type of our new first name. Is it strictly equal to a string? And is our new first name's length property greater than 0? If all of that checks out, we will assign this private first name equal to the new first name we receive. Else, let's console.error first name must be a non-empty string. Let's see if this works. I'm going to save. First name must be a non-empty string, and currently our first name is undefined. Okay, that worked. Let's copy our setter for our first
Alright, so basically we're just setting a type validation, yeah, for each time we try to assign
name.
first name.
Paste it. Change every instance of first name to last name. New last name. Check if the type of our last name is equal to a string and if our new last name
Okay, so we need to change that. Um, let's change those two first. For these, as such, we'll show that the first, uh, part of it is capitalized. I need to follow that camel case.
name, the length of it is greater than 0. If it is, assign the private last name property equal to the new last name. Else, last name must be a non-empty string. That also worked. Our first name and last name are undefined. Let's do this with age.
So basically this should error out, right? Yeah.
Set our age. The parameter is going to be new age. Using an if statement, is the type of new age strictly equal to a data type of number? And is our new age greater than or equal to 0? If it is, take this private age equals our new age. Else, we're going to console.error. Age must be a non-negative number. We can no longer assign pizza for our age, unfortunately. All right, we have our setter set up. Now let's work on the getters. Let's assign
Viewer count is at 2 right now. Hey to who was watching, welcome to the stream. Yeah, what am I trying to do here? Yeah, let's just have this setter made for each. For some reason, I typed out pop that. Okay, so it must be a non-negative number.
some legitimate values. For the first name, SpongeBob. Last name, SquarePants. Age, 30. We don't have those errors anymore. That means they're set, but those properties aren't readable. That's why we need getters. Let's get the first name. Get first name. Return this private first name.
So this should work for everything, right? I mean, if we put it as a negative number, that won't work. Yeah. So put that to a valid age. Oh
Here's
yeah, we
SpongeBob.
won't get the properties because we still need to write the getters there.
His first name. Get last name. Return this private last name. There's his last name. Let's create a getter for a full name too. Let's console.log a full name, even though we have no property for that. That's undefined. We'll use a getter to mimic a full name property by just combining the first name and the last name properties. Get full name. Return. I'm going to use some string concatenation. This private first name plus a space
So we
character.
don't need to actually like call a function as such, and we'll have the like we can call it as we call an attribute really. Yeah. Although it would have been better if the syntax for it was, I'm pretty sure there might be a way to like shorten it out, right? Like most of the times, if you do realize you need a getter, you can just, you should have some sort of shorthand for it, I believe. Maybe there is, and he might tell us about that maybe. Anyhow, yeah,
This private last name.
that's my thought, anyways.
And there's his full name, SpongeBob SquarePants. And the age. Get age. Return this private age. And SpongeBob is 30. All right, everybody, those are getters and setters. Getters are special methods that make a private age. And SpongeBob is 30. All right, everybody, those are getters and setters. Getters are special methods that make a property readable. Setters are special methods that make a property writable. By using a
I just console.log all the properties here real quick. So we actually console.log the full name and the age first. Then we'll set the first name to Patrick. Was it? What was his last name? Star, right? Patrick Star. So, a person dot first name should be Patrick. Person dot last name should be Star. And if we try to log full name again, should work. I forgot. I mean, VS Code should, uh, you know, auto complete it. I believe, Patrick Star. Okay, what if it doesn't? It throws an error, but it doesn't throw. It doesn't abort the script or anything.
combination of both, we can validate and modify a value when reading or writing a property. And well, everybody, those are getters and setters in JavaScript. Hey, what's good, everybody? So in today's video, I'm going to give you a lesson in destructuring in JavaScript. Destructuring allows us to extract values from arrays and objects, then assign them to variables in a convenient way. We can use straight brackets to perform array destructuring, or curly braces to perform object destructuring. I'll give you 5 different examples.
Is this like in Python you can do something like this? Oops. Why can't I hit the space? Not space. I'm actually trying to hit comma and it's not working for some reason. Yeah, I was just saying we can do this and it works. I believe we can also do star just in case we don't know how many values there. Although I'm doubtful on the star thing, we can also just do a comma for variables. I think it's called throwaway variables is the like the technical term. Yeah. So yeah, my point is that what destructuring is in JS.
Example 1. Swap the value of 2 variables. We'll have let A equal 1, let B equal 2. To use array destructuring, we need a set of straight brackets. Add the variables A, comma, B. This will equal, we're creating a new array on the right-hand side. B, comma.
I believe then there was a shorthand for that in Python to destructuring and okay, so I got the meaning of destructuring wrong perhaps, but I'll just see here. Or never mind, destructuring is still that, but swapping. Let's just type that. Yep. Not a program. I just that's a shorthand. Yeah, x comma y is equal to y comma x.
Comma A. On the left-hand side of our equals, we're using destructuring. On the right-hand side, we're creating an array. Let's see what's within variables A and B. Console.log, variable A, then variable B. So if these values are swapped, we should have 2, then 1, not 1 and 2. That's example 1. We can use destructuring to swap the value of 2 variables.
I guess you have to do it in an array. Like this is the syntax. You can't just do a comma b is equal to b comma a. That would be too Pythonic, I guess. Okay.
Example 2. We can swap
Yeah, why do I keep on closing uh the localhost here? Okay.
2 elements in an array. Let's create an array of colors. Const colors equals an array. Pick some colors. I'll go with RGB, so that would be red, green, blue. Let's add black and white. Suppose I would like to swap the position of the first element and the last element. This first element has an index of 0. This particular last element has an index of 4. Again, we're going to use array destructuring. We need a set of straight brackets. We'll take array colors at index of 0, comma, array at index of 4. We want to swap red with white. 0, 1, 2, 3, 4. That's the fourth index. Equals, we're creating a new array by using straight brackets. Colors at index 4, comma, colors at index 0. Then let's print our array. Console.log array of colors. There we go. We have.
I didn't know you could do that. Can I do something similar, like in a similar format in Python? Swapping in array Python. There. You have to use the index itself. Yes, yeah, if you know the index, I mean, that is what they're doing in a sense, yes, and as yeah, I guess the same thing applies in Python too in that case. Because I didn't know that existed in Python, so that's something new.
White, green, blue, black.
Actually, I want to try something out here. So let me go ahead and console.log colors. Just check the output there. Keep forgetting about the semicolons. So switch white to red. So yeah, red is at the end. Can I? What happens if I do this? Let's just for a moment just see what happened there. So towards the end, green got applied. What's in green's position now? Oh, it replaced. Oh, white is still there, but red isn't there. Red just gets deleted.
Black, red.
Rather than
That's how we use the
swapping, I
structuring to
guess
swap
I,
two elements
I
in an array.
removed a value.
Example 3, we can assign array elements to variables. We'll declare a bunch of variables. Const, we'll use destructuring. We're
And I
destructuring an
don't
array, we need a set of straight
delete
brackets.
that.
We'll create some variable names. First color, second color, third color. I will assign this equal to our array colors. Let's print these variables. Console.log, our first color, we have red, second color, green, third color, blue. You could combine array destructuring with rest parameters. We have 2 colors left. Let's assign that to a new.
Oh, okay, alright. I see where this is going. I guess you don't have to do every color and it still works. But okay, I'm just gonna stop that. I'm comparing everything to Python, aren't I? Okay,
array. We'll use rest parameters. I will name this array extra colors. Then we will console.log extra colors, and that should be a new array that has the remaining colors, black and white. That's how to assign array elements to variables using.
oh, alright, you just do this and it gives you an array of colors. That's cool. What if you actually had this and then you used this? Does it just give you an empty list? Does it add a route? What happens? It is 3 dots, right? Yeah, there you go. So let me also console.log extra colors. Of course, can't forget about the semicolon. Yeah, it gives an empty array. If I remove A and S, if I just remove S, it should give me Y in array format. Yeah, there we go.
Using destructuring. Example 4, extract values from objects. We'll create 2 people objects. Const, person1. Person1 will have a few properties. First name will be SpongeBob. Last name will be SquarePants. Age will be 30. And a job, meaning occupation. Not John, job. His job is that he is a fry cook. Alright, let's copy person1. Looks like that N should be capital in last name. Alright, let's copy person1, paste it, change person1 to person2. The first name of person2 will be Patrick. Last name, Star. Age will be 34. Person2 is not going to have a job property. He's unemployed. Using destructuring, I can extract values from these objects. we'll create a few variables. Const, we'll use object destructuring. We need a set of curly braces this time. We'll create these variables. First name, last name, age, and job. Now this equals, let's start with person 1. Let's display these variables. Console.log. First name is SpongeBob.
Fry cook. I heard of cook, but this is the first time I'm hearing fry cook. Alright, then can't have Patrick without SpongeBob. I mean SpongeBob without Patrick. Okay, let's just continue. And have yeah.
Display these variables. Console.log. First name is SpongeBob. Last
Oh, we extract the values. Is it in a particular order then?
name, SquarePants. Age,
I
30.
believe the order matters. And he did it in this way rather than using an array. Guess for objects you have to do it in this way. And if I console.log all these values, let's do that. And let's just see. And what if you do this? Age become the last name then? Interesting. Look at that. Age did not become the last name. It recognized what it's gonna do age. Okay. If I remove this, if I put this here, it recognizes the variable name. So can I have this? You need it to be the exact attribute name. Like the variable name should be the exact attribute name. What if when you have this? You can't. You can't have that. If the attribute name is different, it returns undefined.
Job, fry cook. Let's do this with person 2. Patrick Star is age 34. Person 2 does not have a job property. Person 1 does though. Our job variable is undefined, as you can see here. You can set default values when using destructuring. If somebody doesn't have a job property, we'll set job to equal unemployed. Let's see if that works. Yep, Patrick Star, age 34. His job is
Okay.
he's unemployed. That's how you can extract values from objects. Values extracted can even have default values. Alright, last example. We can destructure in function parameters. We can pass an object to a function and destructure it when it's passed in. Let's create a function. We will create a function to display a person. With the parameters, we'll use destructuring. We're destructuring an object. We need a set of curly braces. We'll receive an object, such as this. I'm going to invoke display person. We'll pass in person 1 as an argument. When we receive person 1 as an argument, we'll destructure that object right away. We will create a first name parameter, last name, age, and job. All we'll do is print a few lines using console.log. I'll use a template string. Let's say name, colon space. I'll add a placeholder, first name, and last name. Let's add a new line. Age, colon space, add a placeholder, age.
Oh, so for like very huge functions, I guess it saves you some lines of code. It doesn't get too messy. But if you kind of change the attribute name, then it I guess in case of objects like you have to specifically go to that particular object and change the name. So I guess it would be fine. Like the likelihood of that happening is really low. Also, I can see that there's someone else on the stream right now. Hey to whoever's watching, I appreciate you being here. So, let me just set this. See if this works. Why did that bring up command prompt? There's something I'll never figure out. I don't know. Like, I think maybe if I repeatedly press Control C, or maybe I'm pressing the Windows and C combo by accident. Okay.
Then lastly, job. Job, colon space, add a placeholder, job. We're passing in person 1 and destructuring it. We should display name, SpongeBob SquarePants, age 30, job, fry cook. Let's pass in person 2 as an argument. Name, Patrick Star, age 34, job is undefined. Again, we can set a default value when destructuring. If an object doesn't have a job property, we will set that equal to be unemployed. Patrick Star, age 34, job unemployed. Then if we pass in person 1 again, his job should not be unemployed. He's a fry cook. There is a job property, so we do not.
So, this is called display person real quick. We pass in person 1, and we'll also pass in person 2 and comment out this line. Let's see what we get. SpongeBob SquarePants, age 30, fry cook, Patrick Star, 34, unemployed. Yeah, there we go. That worked. That worked.
Not use the default value. Alright, everybody, so those are a few examples of destructuring. There's a lot you can do with destructuring. You use a set of straight brackets to perform array destructuring, or curly braces for object destructuring. They allow you to extract values from arrays and objects, then assign them to variables in a convenient way. And well, that is destructuring in JavaScript. So yeah, we're doing a thing today. Today I gotta explain nested objects in JavaScript.
Alright, I think I'll end the stream here. We have finally reached or actually crossed the 6 hour mark, where, we have crossed the halfway mark, and yeah, I'm really happy with all the things we learned today, particularly, yes, today was more about JS, like actual, like, when I say actual, like, it's not the basics, but, you know, something which you learn in kind of the intermediate side of when you learn a language. Yes, or I don't think we can say them as intermediate things, but yeah, I hope you get the point of what I'm trying to say, anyways. Um, so yeah, so we crossed the halfway mark, and I'm really happy with what we learned today. Um, and yeah, I'll see you in the next one. you know, um, yeah. How many segments left? So in segment 46 and 75 and 46, we just have 29 segments left, but I guess since some of them are gonna be projects, they're gonna be yeah. Okay, I get, yeah, lot of projects have eats us. So okay, really cool. And yeah, with that, I'm gonna end the stream. This is me, Shahjan AI, signing off. I'll see you in the next one. Till then, take care. See ya.